What's up guys, welcome to Rotor Riot and welcome back to Learn to FPV. On this episode we're going to talk about ESCs, or electronic speed controllers. So I'll run down the different specs you're going to find on them and give you a few things to look for when you're choosing an ESC and the different considerations you're going to have to take into account. So the different specs that you're going to find when you're looking at ESCs are the current rating, the input voltage capability, the different protocols that are available with that ESC, the size and dimensions of it, whether or not it's an individual ESC like these or if it's a foreign one like these, and then the different processors that can come in an ESC. So first up, for current rating, you need to make sure that the ESC that you pick is going to be able to handle the current that you're going to pull through it. It's not an exact science that like down to a specific number. There's usually a range that will work, but typically the higher you go, the kind of more headroom you have and the more you can feel safe that you're not going to blow that ESC up because you're pulling too much power through it. A common misconception that some beginners think about the current rating on ESCs is that if it's rated for higher, it's going to make more power, but that's not how it works. It's not higher the number, more power it makes, it's the more that it can handle to flow through it. So just realize that you're not going to get more power out of going with a higher rated ESC. It just is possible to push more power through it and without it burning up on you. Next we have input voltage. This is going to be really important because you want to make sure that whatever battery you're going to use is going to work with the speed controller. This is going to be listed on every product listing for every speed controller. There'll usually be a range. It'll say like 2 to 3S, 4 to 6S. So just make sure that the ESC that you're picking is going to work with the battery that you're going to use. Or make sure that you're picking a battery that's going to work with the ESCs that you have. Then you have the dimensions, or the size and the weight. This is not as critical because, I mean, typically ESCs are not too far from each other, but in certain situations, maybe you're trying to be as lightweight as possible, so you want to make sure you have the smallest ESC as possible. These are all ones I've used on very similar setups, so obviously that one's quite a bit bigger than this one. So by using these, I'm saving some weight, and different frames are going to have different widths of the arm, so it may just bug you if the ESC is wider than the arm. It's not a huge deal either way, but just something to look at is the dimensions and the weight. The next one is where it starts to get a little technical, a little tricky, and I'm not going to go too deep into it and overwhelm the beginners, but this is the different protocols that the ESC is capable of handling. So how do I explain this simply? The protocol is essentially the way that the ESC and the flight controller are communicating with each other. So it's basically the signal flow that's happening between the two. And there's different methods and different speeds at which these can run. So when I say speed, what I mean is the way that the ESC and the flight controller are working is it works in a cycle. So it's kind of looking at where is the drone, or what's the status that's going on, what corrections need to be made. Do I need to speed up these motors or slow these motors down? And then it gives that correction and then it repeats over again. So when you have a faster protocol, when paired up with a fast enough processor on the flight controller, this is what's going to make a huge difference in the way that the drone flies. When it can very quickly make these little micro adjustments and do it without adding too much signal noise or being harsh on the system, this is what's going to give you a really smooth flying drone. The two main protocols you're going to find are one-shot and D-shot. There's a little bit more to it there. It's actually one-shot 125, and then in the D-shot realm you've got D-shot 150, D-shot 300, 600, and 1200. Essentially the different numbers mean it's a shorter pulse width and essentially a faster refresh rate. At one point, one shot was like the bee's knees. This was a big advance in the way that the protocols are communicating with the flight controller. But at this point, it's a bit outdated. Pretty much any current ESC, you're going to want to use D-shot. So what D-shot is, it's not only a faster refresh rate, it's also a digital protocol. A big advantage to having a digital protocol is there's more commands that you can send from the flight controller to the speed controller. So the two huge things that I use and a lot of pilots are going to take advantage of is, one is you can use your actual ESC to send a signal to the motor to be a beeper. So when you plug in your drone and you hear those beeps, that's actually the ESC sending signals to the motor, and the motor is what's actually making those tones. And with D-Shot, a way you can take advantage of that is the motor can become your lost model beeper. So when you crash and you're not sure where you went down, you don't know where the drone is, having D-Shot enables you to flick a switch on the radio and the ESC will make that motor make a beeping sound, so it makes it easier to find. Another big one that comes in really handy is turtle mode. So what turtle mode is, if you crash upside down, using D-Shot's communication abilities, you can tell the ESCs, I want you to take 2 of those motors and reverse the direction. So when you give it an input, they're going to spin backwards and you can actually flip the drone over. Aside from it flies better, those 2 features alone would be enough that I would definitely recommend you may as well just go for D-Shot. The difference in price between an older one-shot and a cheap D-Shot ESC is very negligible. So at this point, I would at least get something that has D-Shot. Aside from that, the next sort of advancement that came along with ESCs is having a 32-bit processor on them. So the pretty much best of the best you're going to find right now is a D-Shot 1200 with a 32-bit processor. Having that 32-bit processor is just going to open up more features that an ESC is going to be capable of doing. So now with the 32-bit, you can pull in telemetry information from your ESC, so you can know exactly how much current that each one's pulling. You can know the RPM of the motor. You can also add and modify the tones that it's going to play when it starts up, which is, you know, some people have a lot of fun with that. It's not a huge deal. And it's also just going to be more future-proof. More features that come down the pipeline are probably going to be created for the latest tech that we have. And then the last main spec that you'll see is whether or not the ESC you're looking at is an individual or a 4-in-1. And then in the 4-in-1s, you're going to have different sizes. So this is a 30 by 30. They also make them in 20 by 20, and I think also 16 by 16. So depending on which size of drone you're intending to build, that's going to play into which size ESC you need. You would probably want to go with the smallest one available, but you also need to make sure that it can handle the current and the input voltage of what you're trying to build around. Now for some considerations when you're picking an ESC. The first one would be whether or not you're going to go for a 4-in-1 or an individual ESC. They both have their pros and cons. I kind of already went over this when I did the gear overview video, but we'll do it again here. 4-in-1, obviously it's less parts to buy. You only need one, you don't need to buy 4 of them. It's going to be a little bit more compact, a little bit less weight because there's a lot less wires. And speaking of the wires, there's a lot less wires to solder to, because on an individual ESC, you got 4 wires coming off the top and you're going to solder 3 to the bottom, and you're going to do that 4 times. Whereas with a 4-in-1, there's just going to be the 3 motor wires need to attach for each motor. And then the rest of the wiring is just going to be in a wiring harness that usually will just plug right into your flight controller. So a little bit easier to build over here. But the upside of a individual ESC is if you have a problem with an ESC, you only need to replace the one that's gone bad. Whereas with a 4-in-1, if you have any issues, you're replacing the whole thing. So in some cases, it can be a little bit cheaper to go with a 4-in-1. A lot of times the price of these is less than if you were to add 4 of these together, but not always, and not always in the long run when you're replacing them. Another thing to think about is the different sort of ecosystems of ESCs. So you've got BL Heli or BL Heli 32, that's the 32-bit version of BL Heli. This is like the widest range and probably the most common one you're going to find out there. There's tons of different ESCs available in BL Heli. Next you have KISS. When you're looking at KISS ESCs, it's not like BL Heli. BL Heli, at least the original BL Heli, was an open sourced project, so any company could make an ESC hardware that ran with the BL Heli software. Whereas KISS is closed source, so the only KISS hardware you find is kind of all within that same company and family of KISS. So there's not 100 different ESCs out there that are KISS software compatible. It's just whatever KISS is making. But the upside of KISS is they've always been known to be very high quality and perform really well. Downside being they're also a lot more expensive than your normal BL Heli or BL Heli 32 ESC. Another thing to think about as far as KISS goes is they also have their own flight controller and their own flight control software. So that's kind of why I say it's like an ecosystem. Typically, if you're going to go for KISS, you're going to go KISS flight controller and ESCs, and you're going to like stay within that. It's kind of like going Apple versus Android. And then the other one that you'll find is Flight 1. I'm pretty sure Flight 1 ESCs are the same as what BL Heli runs, but still just thinking about that ecosystem, it's more their flight controller that has its own hardware and software, and it's similar to KISS. It's closed source, so you don't find just random companies making Flight 1 products. It's the Flight 1 company, they make their own things. And like I said, I do believe their ESCs are kind of run the same hardware as any BL Heli ESC, and you can also use BL Heli ESCs with their flight controller. But it's just something to think about of staying in the ecosystem. I think a lot of people who are going to use their flight controller will probably pair it with their ESC because they know it's going to work well together. It's been developed that way from the company. Another thing to think about is wiring and pinouts. So especially if you go for a 4-in-1, like I said, there's usually a wire harness that comes off of this. So it's going to be like, 6 or 7 wires that all go into one harness. And in some cases, you can just plug that directly into a flight controller. But the problem is there's not a standard. So not every 4-in-1 and every flight controller are going to be pinned out the exact same way. So it's usually a smart idea to buy it as a bundle. Buy one company's 4-in-1 ESC that goes with their flight controller. That way you can just plug it right in. If you mix and match, you need to look at the diagram of the ESC and the flight controller. And then you just look across and you make sure that they match. If they don't match, what you need to do is pull the pins out of the harness and rearrange them so that they're correct for the opposite end. And then with individual ESCs, the only thing to think about really with wiring, sometimes the ESC is going to come with the wires already on it. Sometimes it's not. They call it like naked. It won't come with any wire, which is not a huge deal. Wire's pretty easy to come across. It's just good to know whether or not your ESC is or is not going to come with wire. That way you don't get all your parts, you're excited to build, and you realize, oh, there's no wire on the ESCs, and now I have to order wire and wait before I can even build the thing. So wiring harnesses and whether or not it does or doesn't come with wire, it's another thing to think about. And lastly, there's price. There's definitely a range of different prices in speed controllers, and there's a ton of them out there. Like a lot of things that I recommend, I would say shoot for middle of the road if you're a beginner. You're not going to need the most expensive and the most advanced and feature-rich ESC to get flying, but you also don't want to get the cheapest one you can find either. You don't want it to burn up or fail on you. You don't want to have poor flight performance. The main thing is get an ESC that has the current capability that you need for your drone. Make sure it can handle the voltage that you're going to put into it, and at the very least get one that can do D-Shot 600. That's going to enable you to have a beeper, do turtle mode, and it should perform very well. So that's going to do it for ESCs. I hope this was somewhat informative. I know I didn't go into too much detail on this, but to be honest, I'm not an expert on how ESCs work, and for a beginner, I really don't think it's important to go into all the details of how all the different protocols work and the hardware that's on the ESC. There's a wide variety of ESCs that will work for you. So once again, go for a middle of the road price point, make sure it has D-Shot, and it can handle the current that you need. That's all that's really going to matter for a beginner drone pilot. So with that, thanks for watching, and this has been Learn to FPV.